Okay, so now we're going to start actually doing some trigonometry in this, and one thing that I want you to remember from your time in geometry is if you remember the acronym TOA, and what that means is the sine of some angle equals the opposite side over the hypotenuse. The cosine of some angle equals the adjacent over the hypotenuse, and the tangent of some angle equals the opposite over the adjacent. Now, for this lesson, this part, we're only going to concentrate on the sine and cosine, and we'll look at the rest of the tangent and the rest of the trig ratios in section 4. So what David Lippman did in his textbook is, and it's not just David Lippman, but if you remember that the sine is the opposite over the hypotenuse, do you see how here's my reference triangle for some angular rotation, and here's the angle. Remember, the reference angle is always made back to the x-axis, and here's the opposite side. Here's the hypotenuse. Notice how we have these labeled y and r, so that's the radius. So y and r, and then the adjacent side in the hypotenuse is labeled x and r, and that's why he's saying the sine function is the sine ratio is the y side, the opposite side, divided by the hypotenuse, or the r, or y over r, and the cosine function is x over r, or the adjacent over the hypotenuse. And it doesn't matter which way you think about this, but what does really help is on the unit circle, and that means that's like the circle you made in class the other day. The radius is 1, so if I want to talk about the angles, actually, let me put that on hold and let's do example 1, because that's not on the unit circle. Let's graph that. So example 1, I have got some point 3, 4 right here. So here's that triangle. Here's the reference angle where they told us that if this point's 3, 4, we know the x value is 3, the y value is 4, and then they're telling us 5, that the radius is 5. I'm hoping you remember that this is a 3, 4, 5 triangle, and take a look on the back of my room at Oxbow, and you'll see that the Pythagorean triple shortcuts. So what's the sine and cosine of this angular rotation? Well, we know that the cosine is the adjacent side over the hypotenuse, or x over r, if you want to think about it this way. So x is 3, r is 5. The cosine of that angle is going to be 3 over 5. Then for the sine's the opposite side over the hypotenuse, or y over r. In that case, it'll be 4 over 5. And that'll work for any triangle that's similar to this. Now, to kick it down the road further, and I started to talk about that, is what happens when you can't find the angle, when you can't draw a reference triangle like this, like the sine of 90 and the cosine of 90. Well, if you remember about how the sine function is the y coordinate, or the y side over the r, well, where we go with this is, if I'm on the unit circle, and for that last one I just drew, instead of having a radius of 5, I want to have a radius of 1. If I want to have a similar triangle, all I'm really going to do is divide everything by 5, and that's just because it's this problem. So that tells me the y values 3 over 5, the x values 4. Actually, do I have those backwards? I have those backwards. Let me undo it. This will be 3 over 5, and this will be 4 over 5. That makes the coordinates of that point 3/5, because that's the x-coordinate. 4/5 is the y-coordinate. And then if I want to talk about the sine of that angle, isn't that just going to be 4 over 5 divided by 1, which is just 4 over 5. And the cosine of that angle will be 3 over 5 divided by 1, which is just 3 over 5. So where we can go with this is if you're on the unit circle, it just so happens that the cosine, if you can find the point that's on the circle, the cosine of that angle is the x-coordinate, and the sine of that angle is the y-coordinate. So why is that important? Well, they're asking me to find, in example 2 here, they're asking me to find the cosine and sine of 90 degrees. Well, that's a quadrantal angle. I can't draw the reference triangle. I can't do much with that. But I do know the radius is 1 because I'm making it on the unit circle, just like I made this other one be on the unit circle and didn't change the values, right? Well, it didn't change the sine and the cosine. So the coordinates at this point is 0, because x is 0, y is 1, because that's the angular rotation, right, at 90 degrees. So my x is 0, my y is 1. If we go back up and look at this way to think about it, I can say that the cosine of 90 degrees is 0. I can say that the sine of 90 degrees is 1 just by looking at the point. Now, let's see, let me erase it. What you want to do now is you can stop this video and see if you can't do this one. And if you can't do it, you can keep watching or try it and then come on back and watch how I do it. Okay, so I drew out my angular rotation. I labeled my point. It's on the unit circle, so I know the x-coordinate is -1, the y is 0. And then what's the cosine of that? What's the cosine? What is the cosine of pi? Well, cosine of pi is the same as the x-coordinate, so the cosine of pi radians is -1, and the sine of pi radians is 0. Oops, I shouldn't be writing that as theta. I should be writing that as 0. Okay, so remember, find the coordinates at the point, and then put it on the unit circle, and you're golden. So I'm going to show you a couple of ways to do this one. We could do it on the unit circle, just be consistent with what I've just showed you. They told me that theta is in the second quadrant. If I'm on the unit circle, the radius is 1. They're telling me the sine is 3 over 7. And they want me to find the cosine. Well, I know the y value at that point is 3 over 7. I don't know the x value yet. So, but because this is a right triangle, I can use Pythagorean Theorem. So I can say that 3 over 7 squared plus my x value squared equals 1 squared. If I square everything, I'm going to get 9 over 49 plus x squared equals 1. I'm going to subtract 9 over 49. So 1 minus 9 over 49 becomes 49 over 49 minus 9 over 49, because I got to get common denominators. So x squared equals 40 over 49. Now I'm going to take the square root of this. And the square root of 40 I can think of as 2 square roots of 10, because the square root of 40 is 4. Well, 4 times 10 is 40, and the square root of 4 is 2. Over 7, because the square root of 49, remember, when I take the square root of a fraction, I can take the square root of the top, the square root of the bottom. And when I take a square root, I could have a positive answer and a negative answer. I want you to see, because this is in the quadrant 2, and we know in quadrant 2 all those x coordinates are negative, I'm actually going to want the negative of that. So the cosine of theta, in this case, will be -2 square roots of 10 over 7. So that's one way to do it on the unit circle. The fractions might be throwing you. You might not like that. So let me show you another way to do it, and maybe you'll like this better. This is certainly the easiest way, in my opinion, but that doesn't mean it's right for you. So another way to think about this is if the sine of this angle, whatever that angle is 3 over 7, I could think of that as the opposite side over the hypotenuse, or y over r if you want to consider it that way. Notice we aren't working on the unit circle now. So here, and I'm in quadrant 2 still. I know the opposite side is 3, the radius of the hypotenuse is 7. In order to find the other side, I can just think Pythagorean Theorem, and I will set this up. Remember, it's a squared plus b squared equals c squared, or I can take c, the hypotenuse, square it. So why do I write 42? Just a minute here. 49 minus 9, because 3 squared is 9, and then I'm going to take the square root, and that'll tell me what x is. Notice that I'm getting 40, again, which is going to be 2 square roots of 10. So that's 2 square roots of 10. The x coordinate over here in quadrant 2 is negative. Notice we're going to get the same thing, because if the cosine of the angle equals x over r, in this case it'll be negative 2 square roots of 10 over 7. And maybe this same answer, maybe this works better for you. I don't care which way you do it, as long as you can get there. For example 4, they're asking us to find the coordinates of the point on the circle. So basically that will let us find the sine and the cosine of an angle of pi over 4 radians. So you've done some practice graphing a radian measure on a circle. I'm hoping that you're starting to make the connection that pi over 4 is the same thing as a 45-degree angle. If this is a radius is 6, and we think about that the 45 right triangle shortcut, where this is L, this is L, this is L square root of 2, or the other one was, if this is H, this is 1/2 of H times the square root of 2. This is 1/2 of H times the square root of 2. Yeah, I'm hoping you're seeing, because the 6 is an integer, doesn't have a square root of 2 with it, we're going to go with this pattern over here. So that means we take half the hypotenuse and multiply it by the square root of 2. So that gives me 3 square roots of 2 is the length of that side of this triangle. 3 square roots of 2 is the length of that side of the triangle. And then looking for the coordinates of that point, it's just going to be 3 square roots of 2, 3 square roots of 2. Okay, now that'll let us go on and find the sine and the cosine if we want. Okay, then for question number 2 here, so try it now. Try it if you stop the video and try it if you want. Then come back and see what I've done. Or you can just keep watching if you really don't know what's going on. So I've got a circle. It's got a radius of 3. So all those radii are 3. Here is my angle of 90 degrees, or pi over 2. I know the coordinates of that point because the radius is 3. X is 0, y is 3, and that's what they're asking me to do, is find the points on that circle. Now, one thing about it is we can't say that the sine of 90 degrees, remember how I just talked about how we could talk about cosine theta is x, the x coordinate, sine of the angle is the y coordinate. This only works if this is a unit circle, which is not. This is not the unit circle, so we can't quite go there. Okay, so for this first example, example 5, it says find the reference angle of a 150-degree angle and use it to find the sine and the cosine of 150 degrees. So, well, let's sketch out an angle of 150 degrees. So there's 90. So 150 is not quite as far as 180 degrees. And if this is 150 degrees, somewhere I gave you a little table, I think is back on the very first page of the notes packet. I told you if you had an angle, a positive angular rotation fall in quadrant 2, the way you can find the reference angle is to take 180 and subtract the angle from it, and that leaves you 30. So the reference angle is a 30-degree angle. Now, in this quadrant, I know that x is going to be negative, y is going to be positive. So since I'm on the unit circle and I want to find the coordinates of that point so I can talk about the sine and the cosine, I know that x is going to be negative, which tells me the cosine will be negative and the y will be positive. And then comes the trick. The trick is, what are those sides? How long are those sides? Well, you can do this with the 30-60 right triangle pattern. In fact, maybe we should do that. I know here is a 30-degree angle. This is 1. So the side opposite the 30-degree angle is half the hypotenuse. The side opposite the 60-degree angle is 1/2 the hypotenuse times the square root of 3. And of course I wrote 2 there. Let's see, so the square root of 3 over 2. So the x-coordinate of that point is negative root 3 over 2. The y-coordinate of that point is 1/2. So what's the cosine of 150 degrees? Well, it's negative root 3 over 2. What's the sine of 150 degrees? 1/2. And you can check that in the calculator if you want. So that's how we use reference angles and the unit circle and the coordinates on the point to evaluate the exact values of these trig ratios. I encourage you to try to figure it out this way. It'll help you in the long run. To help you do that, on my wall in my classroom, I have this little table set up. And what this shows you is if you can find the reference angle, notice I've done it in radians also, I've told you what the sine and the cosine and the tangent is where we're going to go with that. Same thing with the 60-degree angle, and all I've done is apply those shortcuts to it. And same thing with a 45-degree angle. So make your sketch, figure out your reference angle. It'll be one of these 3 if it's got a reference triangle. Otherwise, it's a quadrantal, and that takes it, that you're just using the coordinates, right? And that way you can figure out what the sine and cosine is. Okay, so let's keep this in mind as we do the next one. So they're asking me to find the coordinates of an angle. Let's see, the radius. So let's find the coordinates. Okay. Well, I'm going to change this a little bit. I'm going to make an executive decision. Let's pretend I'm going to find the sine of the angle and the cosine of the angle, and then we'll talk about the right angle, the angle, because I want to do what we just did up above, because this is in radians. So 7 pi over 6. Where the heck is that? Well, I know that pi is the same as 6 pi over 6. So if I go 1 more sixth of pi further, that will fall right there down in quadrant 3. So that reference angle right there is pi over 6. And I know that both y and x are negative in that quadrant. So I know that the sine is going to be negative. I'm going to know the cosine is going to be negative, and I know the reference angle is pi over 6. Notice I haven't talked about any degrees. So if I look at my little table on the wall, here my reference angle is pi over 6. That's what the sine will be. That's what the cosine will be. So I can say the sine of 7 pi over 6 is negative 1/2, and the cosine of pi over 6 is negative square root of 3 over 2. Okay, so then it's that easy. Find the reference angle, decide on whether it's positive or negative, and then you're good to go. Now, to answer this question about the radius, well, we can apply that same kind of thinking. If I know this is a 30-60 triangle, the radius is 12, the side opposite the 30-degree angle is going to be half, so it's going to be negative, the y value will be negative 6, and we know the x value will be half the hypotenuse times the square root of 3, so I'm going to write negative 6 square roots of 3 comma negative 6, and that will be the coordinates of that circle. I'm just taking those sine and cosines and multiplying by the radius. Okay, so now why don't you take a look at number 3 and try it. It's kind of like what I just did. See if you can't come up with the answer, and then come back and watch what I did. So I know 5 pi over 3. Well, let's see. I know that 2 pi is all the way around, and if I want to make that so it's a denominator of 3, isn't that 6 pi over 3? So that tells me this angle of rotation is going to fall right about there. I know the reference angle is going to be, well, let's see, if you take 6 pi over 3 minus 5 pi over 3, the reference angle is going to be pi over 3. So how does that work if I know the reference angle? Well, if the reference angle is pi over 3 radians, I know the y value, or the y value will be root 3 over 2, the cosine, the x value will be 1/2. And since I'm on a radius of a circle with a radius of 5 here, let's so I'm down here. I know that this is pi over 3. I know that this is 5. The side, the x value we just said was 1/2. So 1/2 of 5 is 2.5 pi, or 5 over 2 if you want. And then the side opposite the 60-degree angle, or the pi over 3, is the square root of 3 times 2.5. So let's see, how am I going to write this? I guess I'm going to write this as 5 square roots of 3 over 2. It feels cleaner to me. And of course that's negative. The y value is negative down here in quadrant 2. So what are the coordinates at this point? I'm going to write them as 5 over 2, or 2.5, and negative 5 root 3 over 2. I could also write that as 2.5, negative 2.5 root 3, but mixing up decimals and radicals just doesn't feel very clean. Okay, so we're applying all that to it. It's not bad. Now, for this last couple of questions on this page, I'm just going to show you how to do that in class. You want to make sure that your calculator is in degree mode versus in radian mode. If you're doing this at home and you don't have time because you're running behind, go check out YouTube. Plenty of videos on how to do that.